Hello, folks, and welcome to our session, Securing Your AI Frontier today. I assume that a lot of folks are here are interested about AI, and this may be hopefully very relevant to you, right? So, what is my AI frontier? Where did it come from suddenly, right? That's kind of maybe some of you are wondering about that. So, applications power the world, right? It's all about applications, right? But we understand the traditional software development life cycle that powers the applications, right? So you have the waterfall model, the agile model, and a whole bunch of different models. People have really got down to understand how people develop software, and they've built, they have very well-defined phases to software development. We understand risks, we understand security controls, and we have the tools to be able to secure software development starting from phase one all the way down to the end, right? But there is a paradigm shift nowadays, right? Which is that people are starting to develop applications based on AI. And that means the traditional software development model kind of goes out the window, and then we're starting afresh, right? And so how do you keep up with this model? So how do we understand this model? So we will sort of figure out what a development lifecycle for an AI application looks like, right? And then if you understand what that looks like, then you can understand the phases. You can associate risk with each of those phases. You can apply security controls and tools to each of those phases, right? And that helps you identify, mitigate, and prevent attacks and help you safeguard your applications, right? So that's your AI frontier, which is that your enterprises are going to start building AI applications. You might need to secure them. So this is going to help you think about what the AI development lifecycle might look like and how to start thinking about security for each of those phases. I do have a lot of slides to cover, so I might go a bit pretty fast, but I'll be around after the meeting, and I'll take any questions after that. Use my keyboard. All right. So here's how this talk is structured. Right. So let's start off with something we know. Let's start off with how to secure the traditional software development lifecycle. Right. Let's think through the phases. Let's look at the tools that we have available. So we have a reference in terms of where to start and how to build on what we know. Right. And then we will go into AI applications. Now, suddenly, we are in a world where everything is AI, right? And then we hear a lot of buzzwords, multi-agent, like orchestrator, workflow, things like that, right? How did we come here? So we're going to look at a brief history of AI applications, because if you don't know what it is, how do you secure it, right? So we'll first try to understand what the AI applications of today are like, right? And then we will, once we know what it's like, then step 4, we will try to define an AI development lifecycle, right? So we know what an application is. Let's try to put a specific phase in terms of how we might start to think about a lifecycle model for building and maintaining those AI applications. Once you have defined such a lifecycle, you have those phases, right? Now you can apply risks, you can apply security controls and tools, but is that it? This whole AI application cycle is kind of new, right? What are the other strategic challenges that we have to solve for, right? Let's discuss some of those things. Threat landscape for AI. AI has been out there for a while, right? And people have been already attacking it from different angles. There are different vulnerabilities that are already known in some of these models. So what is the real-world threat landscape for AI? So that's what we need to protect against, right, today. So let's see what that looks like. And then finally, we'll get to the good part, which is we have security solutions available for AI development lifecycle, right? Let's discuss what security solutions are available. Cisco and I work for Cisco AI Defense. I'll actually get into that. But we'll show how Cisco is trying to plug those holes and offer you security suites that's going to help you secure this AI development lifecycle. And based off all of this, we'll try to make some conclusions at the end. All right, after the races, here we go. About me. So my name is Prashant Arun. I actually lead the AI Defense product. For those who are new to AI Defense, this is a security for AI product. So for people who are building AI applications, for people who are integrating AI models into their applications, we offer a way of being able to think through and sort of secure their whole life cycle, right? There are different aspects in terms of how you build, how you train, how you deploy, and we're going to walk through some of them today. And then we build security for the whole suite. So what do we do? I mean, day in, day out, my team is a very strong AI and ML team. We are building guardrail models. We are building solutions that are going to help you solve the challenges for tomorrow's AI world. So, and I've mostly been in cybersecurity for the last 20 years. So, I've been through quite a bit. And then, so you may find some of my experience, relatable. All right, so let's start with something we know about, right? The traditional software development lifecycle, how to secure that, or what do we do today? So we know that security begins at the design. You have the requirements and planning step where you have threat modeling, risk assessments. For the design phase, we've got secure by design. We do architecture reviews. We have PR reviews. We have secure coding practices when people are starting to do development. We have PR reviews in place, right? And these are some of the things that we built up. And you notice that each of those phases have specific tools or paradigms associated with it that help you guide and think through risk and controls for each of those phases. Now, this is going to be similar to what we're going to try and do for the AI development lifecycle too. So, once you've developed something, now we're going to be ready to start testing and integrating it. We can use static analysis tools. You can use dynamic analysis tools. We've got SCA, which helps you understand all your libraries, all your third-party dependencies that's kind of feeding into the product, right? And then you have your container scans and your infrastructure security tools as well, right? They are going to help you keep your production assets in place. Production security monitoring. You have very well-defined places, very defined processes in terms of how you deploy, how you secure a deployment. For example, how do you, your automatic security key rotations, right? For applications that require runtime application security protection, you could start to use some of those tools, right? And then, of course, you probably want a whole bunch of logs with respect to your production application that are feeding into a SIEM or like a SIEM and a SOAR process, right? So that you're able to find anomalies in those logs and then detect compromises. And finally, I'm sure you have some kind of an incident playbook so that something happens, you know exactly what to do, and you're able to run through the playbook and account for that particular incident. You probably got audit trails and governance processes associated with some of them as well. So if you have an application in production today, you probably have some version of all of these security controls and tools in place that's going to help you get a good night's sleep at the end of the day, right? Now, what happens? Now let's start thinking about AI. What happens when everybody starts going to AI and all your applications start looking like AI? How are you going to start securing them, right? So how did we get here, right? Suddenly it's agents everywhere, right? Did that happen overnight, or did we get here somewhere? So let's look at what this evolution of AI applications has been, and this is going to help you understand what's going on. What is the deeper technology that's kind of driving this evolution, right? And then that's going to give you a deeper sense of what is inside these AI applications, and then and that's going to help you protect some of them as well. Here's a quick history of AI applications. We started with rule-based chatbots, went to conversation AI. And then there was this whole generative AI phase, ChatGPT came out, and then now everybody's talking about agentic AI. What do these things mean, right? So first is rule-based chatbots. Simple, rule-driven, if-then-else, menu-driven, right? They would try to get you a reservation or whatever. You call somebody, and it's like an IVR kind of thing, right? That's where we started. And then it became a little bit more conversational. There were new NLP models that were being built. You could look at the text and then find out what is the intent of the particular user's conversation. And then you could just navigate those menus a little bit more smartly because you could find the intent, right? You could match intent against those menus. And then we went to generative AI. And ChatGPT came out, right? You could give it a particular complex task, organize a birthday party for me. And then it would give you a detailed set of steps. Talk to the organizer, you got the food to think about, you got your venue, blah, 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 right? So it would give you a detailed series of steps, but then it would stop there. And then you had to go and actually think through each of those things and actually call, you had to call the venue guy, you had to call the food guy, right? And then now comes agentic AI, right? What is different about this is that we give the task to the AI model, and the AI model is able to plan and it's able to reason about it. So in this case, if you want to organize a birthday party, it's going to say that, okay, you're going to need a venue, you're going to need a caterer, blah blah blah. It's going to reason through them. It's going to come up with a particular plan, and this agentic AI is interfaced to a whole bunch of tools, right? And then, for example, you all got systems with like APIs, right? Effectively, this thing is tied into APIs. It can start to make those API calls. It can start to call, I don't know, DoorDash, I don't know what you guys have here, but Uber, whatever, right? And then make those API calls, start booking some of those things, right? And then it's going to act. So that's a big difference. It's going to start acting on it, and then it's going to look at the output, right? So for example, you may make an API call and find that it fails, right? It's going to look at the output and then figure out how to recover and how to make it better, right? So given a complex task, it's able to break it down, and then it's able to interface with the right tools to be able to get things done, right? So previously it was think, but now it's a little bit more acting. So we're bridging the gap between thinking and doing. All right, here we go. RAG. So this is an important piece in terms of how agentic AI is sort of developing, right? RAG stands for Retrieval Augmented Generation, right? It means something very simple. It means that when an AI model is thinking, what data does it have access to, right? So we started with chatbots, and what we used to do was just say, hey, you're trying to answer this question. Here's a relevant document, right? Use this document and answer this question, right? That's where we started. That's where RAG started, right? Effectively a passive lookup. But today, we've kind of turned it inside out. So we have these AI models. Now we make the AI models aware of all this data. It could be a document store. It could be unstructured data. It could be some data hidden in your Slack, in your HRM app, CRM app, whatever. You just make them aware of them, right? And then the model is now able to go out there and fetch the data as it needs, right? So going from passive lookup to active research. And that simply changes the scope and the scale of what the AI application can actually accomplish, right? So here, quickly, given a complex goal, it's able to plan and decompose it into smaller tasks. It's able to retrieve the data that it needs to be able to really understand what's going on, right? It's able to reflect and refine, which simply means that you've probably heard the hallucination problem, right? All right, it just comes up with stuff. But then during the reflect and refine step, you take the output, put it back in the model, and say, what do you think, right? And then when you go through multiple iterations of them, it is able to sort of reflect and refine and get back on track in some sense. So it is able to, or we force it to confront its own hallucination, so to speak. So based off all of this, this is an iteration. This is an iterative process, and then out comes a synthesized result, which is a reasonable result. It might still not be good all the time, but it's starting to do better and better, right? The orchestration layer. So what is traditional software? Traditional software is nothing but a set of pre-programmed paths. You give it an input, you have a particular environmental state, and then you have programmed a path to go from start to finish, right? And then your program is nothing but a whole bunch of such paths for all different kinds of input, for all different kinds of states. That's it, right? If you have a bug, that means that either you kind of forgot about the input, you don't handle it, or something about the environment or the particular program path itself is bad, right? Now the paradigm is different. What we do now is we take a large AI model, and that's like a brain. We take the brain, put it in the middle of the software, and then say, here is an input, here is an environmental state, just do the right thing. That's it. So no pre-programmed paths anymore, completely probabilistic, but then we force it to think and reason over the task multiple times, and then out comes something which is logical and correct most of the time, right? So you don't have to write these volumes of extensive software code, but you've got a model which is able to kind of think through things and get it done, right? So that's the orchestration layer we're talking about. We're talking about a brain which sits in the middle of the software, and then you don't have to program and think about the logic paths anymore. You just ask it to do the right thing, right? All right, multi-agent systems. So once you've built such a system, right? It's got a brain, it's able to interface to a bunch of tools, it's able to get a bunch of things done, right? Now, it turns out that if you build a few of these things, it makes sense to sort of put them together, right? And then get them working in harmony towards solving a single task. So you can start to give much more complex and higher order tasks. And then they will figure out how to sort of partition them and let individual agents sort of work together to be able to do this, right? So multi-agent systems more powerful than single agent ones, so to speak, right? Orchestration frameworks. So we spoke about orchestration. We spoke about how we're going to put this brain in the middle of things, right? I mean, just get it done. There are different ways of being able to just build that kind of software. And then, so here are some examples, some libraries, some frameworks, Crew AI, LangGraph, Autogen. They all come with some very opinionated ways in terms of how to build some of these things. So for example, Crew AI is a role-based orchestrator, which means that you have multiple, you just spawn different roles and then let the model assume the particular role and then force that interaction with the other roles. And that's how you get to an orchestrated behavior, right? LangGraph is a little bit more straightforward. You have, let's say you want to do a task, you define a set of programmatic paths. You define a tree from start to finish, right? It doesn't have to be like a regular software program where you have to think about integers and bytes and if and thens. But what you try to do is to constrain the execution in some way, to keep it to some well-known paths so that you're able to get from start to finish. And finally, you have Autogen. Autogen is a lot more conversational. You just get a bunch of bots spun up and then start talking about the task, and then they kind of automatically figure out and get to a good end, right? So these have been ways of getting to some of these orchestration systems. We got something new in the mix recently. It's called Cloud Skills. And what this is that, you've got one agent. It's really good at something. And then you've got another agent, which is really good at something else, right? And then we talked about how we're going to let the two of them work together, right? But what is different about agent 1 and agent 2? It turns out not so much, actually. It's just the same brain, but then a different set of tools, a different set of data, right? So is there a way to just get one brain to just work with a whole bunch of tools? So that's what's called, Cloud Skills are about, right? It's almost like that Matrix helicopter thing. I mean, I'm in trouble. I got people firing guns at me. I need to fire a helicopter. I'm going to climb up and say, okay, download the pilot thing, right? So that's a skill. And if you want Claude to start piloting a helicopter, you can just add a skill and say, here's how to fly a helicopter. You can provide tools, assets, documents, data under that skill. And when we need to fly a helicopter, it's going to start consulting that skill. It's going to dig deep into that data, figure out how to fly the helicopter, right? That's kind of what you're talking about. So as you can see, things are evolving, but in a kind of a linear direction, if you will, which is to start overloading and building complex systems off of big models. All right, so we talked about big brains going out and using tools, right? How are they doing it? I'm sure that you probably have many systems out there with APIs slapped on top of them, right? So that we had the API world a few years ago. And now what we have is an MCP world. So you have an API layer, you slap an MCP layer on top of it, right? And then you allow the model to be able to understand an interface to that MCP layer. So it's a very simple MCP layer, which is just JSON RPC, which established some simple tool descriptions and things like that. And that allows the model to standardize the way that it interacts and calls effectively APIs against a whole bunch of different things. So that's what MCP is all about, right? A2A, so you have two smart agents. They're talking to their own tools, probably built by two different organizations. Let's say FedEx and Google. They want to talk to each other, right? They're going to spin up their own agents, and then you can have them communicate with each other and sort of figure out what to do about something. I want to ship something from here to there, right? You could just let the agents kind of figure out what that's like. MCP versus A2A. So I said MCP, I said A2A. So what is it? So MCP is client server, not south traffic, right? So it's an agent invoking tools. That's MCP. That is MCP. It's basically not south. It's client server. A2A is more peer-to-peer, right? And then it's kind of east-west is how I would think about it. Okay. Okay, so all that, and finally, now you guys know about everything, right? I mean, you know about RAG, and you know about cloud skills, and you got everything now. So where are we now? So if now people are going to start developing applications based off these paradigms, based off of MCP, based off of A2A, right? Based off of RAG, right? Based off of the plan research model, based off the agentic orchestration model, right? That's how people are going to start building applications. And now that means that's what you need to secure, right? So meaning just in terms of evolution, we've gone from chatbots to more capable workforce. And then from a single monolith to more modular systems, because you have agents that are able to talk to each other and then build and then be able to work with each other, for example, right? And protocols like MCP and A2A are also making things a lot more interoperable, right? So if you've got your legacy systems, you can just slap an API layer on top of them, slap an MCP layer on top of them, and then get a model to sort of work with them, right? So everything is becoming a more interoperable, and also a much more potentially a very peer-to-peer world, right? You don't need your assistant, or you don't need to call somebody. You can have your assistant agent call their assistant agent to set up a calendar appointment, right? So think about that, right? A lot of what we hear, right, about AI and the cutting edge of AI is really about individuals being able to start using models and sort of improving their daily workflow, their calendar, their PC, their browsing, right? You hear a lot about that. The other place that you hear a lot about is about software developers, right? They're starting to use Windsurf and Cursor, and then they are tying into their code repositories and generating code and things like that, right? That's what you hear a lot about, right? But there is a silent revolution happening in the back end, and people talk about how enterprises are starting to adopt agents at scale. So here is one case study from Cisco itself, from WebEx, in fact. So where they have something called a contact center, which is nothing but a call center, right? People call in and then they get help, right? And usually it's a lot of people picking up phone calls, which is where it all started. But nowadays, it's really about, in this particular case, for the healthcare booking workflow, there is an orchestrator that understands the input, and then it's able to break it down into very specific tasks. Call the insurance, call the hospital, check your check your calendar, and then be able to book the right appointment. So this is something that that's kind of been deployed and looks like they're getting quite some traction and success with this, right? So it's a real-time example of an enterprise agent system, right? And then you're going to be seeing more of these getting quite prevalent very soon, right? And therefore, something to secure. All right, so you guys are good now. I mean, you guys know about AI applications, what it has. I mean, how it evolved, what is the technology going at, how it talks to others. MCP, A2A, you got everything, right? Now, think about developers building these applications, right? What is that development lifecycle going to look like? Let's see. But before we go there, I just want to quickly mention the model development lifecycle. This is not new, right? People have been deploying models for about 20 years, I think, right? I mean, Google's every time you go on the web and look at some kind of a browser, you get an ad, and that's based off of some kind of a recommendation system, which is driven by a model, right? And then ads have been around in Google for like a while now, right? So people are used to developing models already. There is already a clear process in terms of how model development happens, right? And there is a life cycle. I'll go into the details of that, but the way to think about this is that if you have a complex agentic system that's not based off of just one model, now a complex system is going to have multiple models doing some very specialized things, right? Depends on what you want to try and do. And some other systems could also be composed of just one big model, which can do everything, right? So it depends on how the system is engineered. In this case, how that particular application is engineered, right? And if you have many specialized models doing specialized things, then each of those models will need its own life cycle, right? You got to think about how you're going to build that model, what training data you're going to use, how you're going to evaluate the model, and then once you put that model in production, then you have to watch it constantly to understand how well it's doing, right? And is it still working? What is the drift? And whether what you're seeing in the real world is starting to differ from what you trained the model on, right? So that's the model lifecycle, right? Smaller models or something like that which fit into a larger piece of the puzzle, right? Now let's get deeper into the agentic lifecycle. Now this is where we're starting to really think beyond the boundaries, right? So we talked about multi-agent systems. We know about AI applications. So let's imagine what an AI agentic lifecycle for development actually might look like. The first step could be around ideation and design, right? You want to define the goals, the personas, and things like that. A lot of it comes down to being able to build some clear specifications in just natural text, right? You want to have a clear hierarchy of specifications in terms of how your system is composed, and this is basically what could be the result of an ideation and design phase of the AI application development, right? The next phase is the actual development. Now you have a spec, you understand what you understand what to do as part of your overall system architecture. You go off and start building assets around them, right? So you need to figure out, hey, what are my prompts I need, right? Which prompts work well, which prompts don't work well. What data am I going to connect the system to? What tools do I need the system to connect to, right? You got to figure all this, start doing some of those integrations, maybe doing some set of local testing to make sure that, well, you know what, all the wires are connected, right? At that point, your development is complete, and then you start to go into some testing, right? You have a system, it's connected to a bunch of stuff, you can feed it a bunch of input and see what happens. That's kind of where you are, right? For the testing, what you want to do is to try and simulate what sort of real-world input you can simulate as best as possible, right? And then see what the output of the system is like. Now, remember, I told you that agentic systems are a lot about giving it a complex goal and then allowing the agent to sort of break it down into smaller steps, think through it, reason over it, refine, act, look at the output, do it again, right? So you want to exercise the system with a bunch of different inputs, see what that output looks like, right? Now, you may give a particular task, and sometimes you may find that it found a very good way to be able to solve it. And then some other times, maybe it kind of meandered all the way and ended up in like no man's land, right? Either of those things are possible. But when it does get something right, what you want to know, you want to start recording that, because that is useful training data that you can now use to get the system to behave a little bit more a little bit more reliably, right? So that's what we call the golden trajectory, which is that the system took a task and did a good job in terms of figuring out how to actually do it, right? And then you need to think about deployment. Now you've got a system, you've tested it as best as you can, you got to start deploying it, right? You want to think about how much traffic you're going to allow into the system, right? And how we are going to start. You don't want to go all out right away, right? You just want to, test some traffic, get some confidence, and then incrementally turn it on for more users, right? That could be one way of doing deployment. And then finally, monitoring. You've enabled the system, it seems to be working, but you have to monitor it constantly to understand what's going on.
When you say there the flags, is that to turn features on and off? So you roll out a few features, and then as you go, you're enabling them?
Yes, you may have a little interaction, you may have a lot of interaction, you may have many different features, right? So if you have granular control over some of those features, some of those capabilities, then you could start to sort of incrementally engage more and more capabilities, right? And then see how the system behaves, get some more confidence in it before you turn it on, right? Otherwise, you're asking for trouble, which is that, Saturday night, you're trying to take your wife to dinner, and then you're going to get that direct call, and then sometimes it's really hard to figure out what's going on. Okay, so going into some more details here with respect to what these phases actually mean. Remember that the more we understand and define each phase clearly, our goal here is to be able to associate clear risk on each of these, risk associated with each of these phases, so that we can start to build security controls, we can build frameworks, and then we can actually build tools that can help, that can help mitigate the risk on each of these phases, right? So the first phase is ideation and design. I think we went through quite a bit here, but bottom line is that you want to define the goals well, you want to set some limits, and then you may want to map it to the kinds of tools and context that you want it to operate on. I mean, you don't want it to operate on some open-ended kind of thing. You probably want it, or at least you want to start with a limited set initially, right? Phase 2 development, again, build a bunch of prompts, figure out how those tool interactions are going, get the plumbing right, do some testing, and then maybe you're ready. Testing and validation. This is an important piece. Now you have a system, right? How do you start testing it, right? So the first test, one of the things is, a very important piece is for you to red team it first. You've got a system, you don't know how it behaves, you think it works. The first thing is for you to try and exercise the system and try and break it, right? The best thing is so that you go in there with your eyes wide open, you know what's happening, you know what works and what doesn't, and then you can plan for those kind of failures, right? That's the first step. Golden trajectories, right? So you collect the times when the model or the system did a good job so that you can use that as training data, you can use that as references. Now, let's say the same kind of task starts to behave very differently later and you don't see those same trajectories anymore. That means you probably have to re-engineer your system in a different way, or maybe something's changed. Maybe some data is not available anymore, maybe a tool is not accessible anymore. It could be anything, right? Behavioral property. And what I mean by this is simply that you have to set some guardrail somewhere, right? You cannot, for example, have an insurance quote worth like $0. You probably want to, impose some limits in terms of how the system behaves and have some hard limits there. And you might need a way of being able to enforce these hard limits at runtime because you may not always be able to trust the system. And finally, unit tests. You probably want to use some of these golden trajectories and try to keep them as unit tests. Just have some sanity around your system. Every time you modify a prompt or some code gets modified, you want to be able to run these sanity tests, make sure that your system looks good before you think about applying it in production. Deployment. We spoke about gradual rollout, right? We spoke about deep tracing. So the difference here comes down to the same thing, which is that if you have code, it's very, very deterministic. You know why you got, if you get log message A and log message B, you know the exact sequence of code that was operated on, right? But here it's not like that. You may get an output, but then you don't know why. You don't know why the model was thinking. So you may need to enable deep tracing, and then you may actually need to log that so that you have the traces. You understand what was the model's trajectory, what was the model's thought process in getting to that bad result, so that you can try to account for that in a different way. Finally, you want to enforce some kind of simple guardrails, make sure that it doesn't go off the reservation, keep that in some kind of bounds, and multiple ways of potentially doing that at runtime independently, right? Monitoring and tuning. Yes, I mean, you put it in with very little work, right? I mean, the brain, after all, the brain's doing all the work. I mean, you don't have to write a lot of logic. But now the hard part, you just have to make sure that it's on the track all the time, right? So you keep looking for all the trajectories, see how it is changing, right? How can you start recording some of the golden ones? How can you baseline the performance in some way of some of these reasoning and complex task execution, right? And then once you have collected enough data, you may be able to fine tune the model, and then once you fine tune, and then you may be able to get the model to perform better more often, right? And that's something that you want to do, right? Or of course, let's say a particular prompt is not working for you. You may go and try different variations of it with more data based on what you've seen in the real world, so that you can iterate on the prompt and get it working better and better, right? So these are pretty much the phases that we came up with, and not me, just all of us, right? We came up with this as part of the AI development lifecycle, right? So we think that these are phases that we can, in which we can structure development for some of these advanced agentic AI applications, right? And now you can potentially start to associate risk and security controls and tools around each of these phases. Is that as simple as that? Or is there something fundamental that we're missing, right? What are the strategic challenges in securing this? Yes, we know the development phases. We know a little bit more about the system, but is that enough? Maybe not. Let's figure out what's going on. Identity and identity delegation. Here's the first strategic challenge. Okay, I hit something. Okay, so no more clouds. So here the issue. I'm sorry. Should I fix that? All right. So the fundamental issue here is that, let's say the user comes up with that particular task. Now the agent is able to break the task down and then get it done, right? The real question is, who did this task actually? All right. Is it the user who's responsible for it, or is it the agent? So here you think about two fundamentally different models, right? You can think about the agent being a delegate of the particular user, or the user has its own identity, right? And then it's effectively its own thing, and it has its own set of permissions and stuff like that, right? So it's about delegation versus the agent being a thing by itself. So this is one of the issues to resolve. The new attack surface. The age of protocols where we have protocol headers, enumerations, and payloads, very fixed payloads, they're gone, right? All these exchanges are now happening purely over natural language, right? You just have a whole bunch of natural language where there's a description of what you want to achieve. And then let's say there is if there is a parameter missing, then the recipient is expected to sort of come back and say, hey, give me this parameter, I need that, right? It's a whole new kind of a protocol. Authorization policy. Static RBAC, you had users, you had roles, they had scopes, they had permissions, right? End of story. But now you have one agent that could do very different things for different users for different tasks, right? So that means that your permissions and your policy are a lot more dynamic. So task-based authorization control, not role-based, but user dependent as well. So which task are you trying for what user, that decides what resources you have access to, right? And how do you design for something like this? Runtime isolation, right? So when an agent talks to a database, right, how does it do it? It generates code. It actually generates code that says, select star from blah, 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 because I need this kind of data, right? So it is generating effectively untrusted code, right? How do you, and then, that means that you got to be careful in terms of how this code executes. And you need to have some runtime isolation around some of this generated code being executed. Data and memory integrity. This is a temporal issue. This is now the agent is expected to learn from the ecosystem. It learns to process data and interface to data at scale, right? But then there could be a lot of ways in which you could just dump a whole bunch of junk or maybe some very targeted attacks into that data, right? And then a month later, you ask it to do something. It looks at some stale data, and in there lies some kind of an instruction, which the agent, which gets picked up, and then suddenly it's completely off track, right? I mean, it's trying to do you've given it a particular goal, but then it read some instruction from some stale stuff, and then it started to go completely out of whack, right? So this is potentially poisoning or temporal corruption, because it is poisoning data over time that might suddenly crop up and manifest in very different ways. AI supply chain security, this is super important. Obviously, you're building a system that has models, data, code, libraries, third-party, data sets, right? And the thing is, how do you secure all this? I mean, if you don't know what the provenance is, what are the security controls for all these dependencies, that means that your system is vulnerable because you don't know what's in there, right? And this is explicitly a bit of a hard challenge, because you may know what a model came from, but you don't know what are the data sets that were used to build this model. That means you really don't know what the model contains and how it could potentially behave in some weird cases, right? In a particular case, in particular situations. Denial of service, you could feed in a particular kind of input, which basically makes the model kind of spin and then spend a lot of money, right? Accountability and governance, obviously. I mean, all of our applications need to be audited. We need to know exactly what happened when, right? And this basically means that you need those thinking traces to understand why a model did what it did, right? So a lot more logging, a lot more variability in logging, a lot more analysis in terms of why a particular situation happened. All right. Threat landscape for AI. Okay. So here's what we did, right? We defined an AI development lifecycle, right? We spoke about the strategic challenges in terms of securing some of those AI applications, right? But what does the real world threat landscape actually look like, right? What are the threats that you need to be, anybody building an AI application or an AI-based system needs to be concerned about? Now, Cisco's AI Defense has an awesome threat team. What they did is they went out there and then they sort of built out an integrated AI safety and security framework. So if you want to know what are the different things you need to be concerned about with respect to securing an AI application, you want to search for this, right? And out comes a very detailed study from A to Z, all the way from physical security down to some kind of a prompt injection. They've got all different categories covered. You can slice and dice in multiple ways. What affects what, MCP, agent, everything. They've got the whole taxonomy laid out. This really helps you think through the exact threat model for any application because you can cover all the aspects that are associated with this. For the purposes of this presentation, we will not be, as intricate, right? Just off the top, these are the 4 main things that apply to models, right? These are the kinds of threats that we are seeing today for some of these models. Let's dive into them. Application security and abuse, right? So this is what we call a prompt injection or a jailbreak. You feed in a particular kind of input that hijacks the model's actual purpose, right? And then it does something else. You ask it to do something, but then somebody fed it an input that made it do something else, right? This is a jailbreak. Model integrity. You are poisoning the long-term state. This is something we've kind of spoke about. Right. One of the things is that one of the examples here could be that somebody sends a calendar invite. This is an actual example. Somebody sent a calendar invite which contains some instructions on to basically send all your private data to a different email, right? Just a calendar appointment. It was just hidden somewhere in the body. Nobody took a second look at it. But now this goes into a database, because that's where all your email is. And what is your personal assistant AI doing? It's reading all those emails, right? It read that email. It thought that there is an instruction. I need to follow it. Okay, I'm going to send a bunch of data to that email address, right? So this is basically temporal poisoning of your data. Okay, infrastructure and supply chain, we spoke about this. Your models, your libraries, your code, right? We need to understand the provenance. They need to get scanned so that things that are coming into your CI/CD pipeline, they are clean, right? And their integrity is completely verified. Evasion and deception. You can deceive an AI model in a variety of ways. A simple thing is obfuscation and encoding, right? You can obfuscate. You can obfuscate the model by using base64 or Morse code and a whole bunch of different techniques to be able to try and get the model to behave in some weird ways. You can pass some hidden instructions to the model, which are not very apparent. Goal hijacking. So we talked about the 4 major ones for models. Now let's get into agentic systems. Goal hijacking. Now you have a complex task for an agent. It's going to break it down and do a whole bunch of stuff. Somewhere in there, you can go ahead and give a new set of instructions that is going to get the model to do something dramatically different, right? That's goal hijacking. Identity deception. Now the agent is operating on behalf of somebody, right? Maybe it's operating on your calendar, on your emails. But what if you're able to spoof the agent into thinking that you're actually somebody else? Then can you go and read, somebody else's emails, right? That's that. Communication compromise. We spoke about multi-agents communicating, right? MCP, talking to tools. All that's happening over natural language and over text, right? What if you're able to get a man in the middle? Now you can start to affect those systems. All right, now let's get to the good part. Security solutions for the AI development lifecycle. So we spoke about the problems, we spoke about the challenges, we've defined a possible development lifecycle. Now let's see what solutions apply to each of those phases in the lifecycle. Okay, first thing is that the good news, we've got security solutions. We're thinking about every one of these phases. We are thinking about how we can help you secure each phase of this AI development lifecycle, right? So standards and governance. Now we got government bodies, we've got nonprofit bodies, we've got OWASP, NIST, MITRE, and I think we have some European bodies as well who are coming up with their own standards in terms of how to think and secure AI systems. Our taxonomy is completely aligned and integrated with those. right? So we account for all those things. So it helps you think through the problem. When you're thinking through the problem, you can use our standards to be able to think through it, right? If you have cloud and models and assets already deployed, right, then the Cisco AI Defense Platform is going to discover them for you, right? So you have that visibility when you're building a new model. Supply chain security, we have a strong story around that. We can scan your repos, your models, your data, understand the provenance, make sure that things entering your CI/CD pipeline are clean, and that's the AI bill of materials as well. So for example, if you have source code, what are the prompts you're using, what are the models you're using, what are the libraries you're using, we can discover them for you. And then you can sort of have that visibility and track them in one place. Training and evaluation, the two big things I want to call out here is first is algorithmic red teaming, right? So we have an algorithmic red teaming product for models, for agents, and the idea here is that just let us at your system, and then we will throw all these adversarial prompts. We will figure out what's working, what's not working. We'll give you a clear report, a standards-based report, which tells you that, okay, here are the vulnerabilities that you need to be concerned about, and then you need to be thinking about protecting against, right? We tell you what's wrong with your system so that you don't have to discover it for yourself in production. And the good news is that as you're building your CI/CD pipeline, you can just integrate this capability right into your CI/CD pipeline, right? And then every time some change happens, you get a new report with what's changed and what is vulnerable. Deployment and operations. The big thing to call out here is basically two things. One is runtime protection, right? So you want absolute guardrails. You don't want your model spewing profanity at somebody, right? Or maybe completely going off the rails. So we have security guardrails, which protect you against prompt injection, safety guardrails, which is for content moderation. You don't want harassment and self-harm and all this kind of content to kind of leave your system, right? And then we have privacy guardrails. So if you're sensitive about if you're sensitive about private data, you can prevent those data from being sent out from the model. Agentic guardrails, we're starting to build protections around them. We can understand the complex goals, and then we can help try to keep the system on track. So we're starting to build protections around those. All right, so quick slide on complete lifecycle coverage. So this is the lifecycle that we defined, and here are some of the protections that we are going to get, right? Obviously, some places more stronger than the others because some of them are a lot more evolving as opposed to some other ones. So for example, our runtime protection is a lot more stronger as compared to a model train protection, where you might want something to secure your data sets and things like that and make sure that no poison data comes in. So some of those capabilities are still being built. All right, we spoke about strategic challenges. Let's see what about those strategic challenges, right? What do we have to do with this? How are we solving those, right? How are we thinking about those? Let's go to them. Identity and delegation. The first thing is that the overall identity problem has not been solved, right? So people still don't know how to do identity for agents. They're just kind of doing their own thing. And mostly they're kind of repurposing OAuths and scopes and trying to figure out if there's a way to get it to work, right? But what we can do for you, okay, this time I did not touch anything, but okay. Yeah, all right. So what we can do for you is this, right? We can provide visibility into what's going on, right? Which users are accessing what agents are accessing what resources. We can tie into your MCP, and then you can build some simple policy controls around them. Don't allow this agent to access this tool, for example, right? And then we track some of these things in a very clear dashboard, so you have clear visibility into what's happening with respect to your identity and what resources are being accessed by what roles. The new attack surface, this is the biggest thing. Again, like I told you, the age of protocols, the whole age of binary protocols gone, right? It's all natural language, instructions being exchanged over the wire in any language, right? That doesn't need to be English. It could be Dutch, right? So that very interesting in terms of how machines are communicating, and therefore imagine being able to firewall on semantic content, right? That's kind of what we do. We look at semantic content, we understand threats at a deep level, and then we are able to sort of know good from bad, right? That's what we want to do. And one of the other important use cases that we're working on is compliance. Obviously, you have different kinds of, compliance, safeguards, policies that you don't want your model, or you want your model to comply, and that means custom guardrails. So we're spending a lot of time building custom guardrails so that you can enforce your custom policies on that input-output that your model is spewing. Okay, authorization and policy, I think we spoke briefly about this, right? Role-based access control versus task-based access control. Here we are able to give you policy so that if a particular tool or a resource is being accessed, then you can apply some level of control on it. You have some level of visibility into what's being accessed. You can view all those things at a dashboard level. But the whole ecosystem is evolving, and then our solutions will be there to sort of help you, keep up with that ecosystem and sort of shepherd you through it. All right, data and memory integrity. I think we spoke about this. Every time there is a prompt injection, somebody tries to send you a bad data that can get into your database, we can block that, right? We can recognize that, we can block that. It never gets into your system, and therefore your system is not poisoned. Runtime isolation. So we have runtime protection, so we can detect malicious code, for example, right? So that way you can have some level of trust that any code that's being generated is not malicious. Supply chain security. This is a place where we invested a lot of time and a lot of effort. So we are able to trace provenance. We're able to scan repos and data sets. Right, and then we are able to inspect your code to give you visibility into what assets and what models and what prompts you have in your code. So we have a complete visibility suite in terms of how do you keep your input into your CI/CD pipeline relatively clean and keep that integrity good. Economic denial of service. We don't have a strong story here, but we can do some level of denial of service protection. Accountability and governance, we have lots of different kinds of logs, right? And then we have Splunk integration, which helps you feed a lot of data into Splunk for you to analyze and report on. MCP logging, we support MCP natively, and we understand MCP deeply. We can get in there and then log those interactions a lot more as well. All right, so a quick slide on the complete coverage, right? So these are some of the challenges we have, and this is how Cisco's AI Defense is solving for some of these things. Right, a lot of what we kind of already spoke about. Okay, all right, just in time. Okay, so here's what we did. We understood what AI applications contained, right? And then we tried to imagine what a development lifecycle for this application would look like. So we had those 5 steps, and then we thought through the security challenges, right? I mean, identity, blah, 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 right? What are the challenges there? And then we spoke about how we are trying to solve for them in AI Defense, right? So now you have some idea of what the stages are, how to think about risk, what sort of tools could apply to each of those phases of AI development lifecycle, as well as how the strategic challenges are being looked at and solved for, right? So let's try and make some conclusions. So the first thing is that, yes, you are going to have an AI development lifecycle at some point, right? Maybe you already have it, right? So multiple pieces to this, which is how do you build a secure foundation? How do you build validation and trust? And then once you have something in production, how do you have runtime governance, right? So all of them present with some challenges, and then there are some solutions in the AI Defense product, for example, that you can apply to those challenges. So you want to understand your life cycle, and then you want to plan for it, and then make use of these kinds of solutions to be able to start securing some of them. Right. One of the things that you could start to think about is that is an operational risk assessment, right? So we can give you a checklist which allows you to start thinking about what have you deployed, right? Some very targeted questions in terms of what are your open risks with respect to AI applications that you may have, or maybe are deployed in a very shadow manner, or right? So you can come up with an operational risk assessment, and this is going to give you a sense of how vulnerable you are, right? And then when do you need to start actively thinking about putting an AI defense solution into your enterprise? And finally, a quick view into what the AI defense dashboard looks like. So it's one pane of glass. It tells you what agents you got, what applications you have. Sorry, some of the numbers are fussed out. Right, this is actually a customer dashboard, I think. And then what are your assets? What are your how many models you have? How many users do you have tied into using some of these things? And then we've got a whole bunch of events which give you visibility into what's going on in your system. And on the right pane, you get some recommendations in terms of what to do, in terms of what we have been able to analyze and then what we've been able to surface, right? And that brings us to the end of the presentation, and I'm about 5 minutes, 30 seconds still on, which I did not think I was going to manage. But I'm open for questions. I'm even open to revisiting some slides. Please.
And it looks very comprehensive, which really means complicated. And it feels like there's a whole systems integration project on its own to take advantage of what's available here. Who does that? That's deployment and drive the adoption of the various components and help the team that are typically swamped anyway.
So let me try to address your question. Perhaps you can ask me a follow-up question, right? So what we are trying to do here is we don't want to completely reinvent the wheel, right? So I think we have established processes for software development. And what we are trying to do here is to, in some way, think about what the equivalent would be for an AI development ecosystem and sort of build those tools out for that, right? So you're still going to have a CI/CD pipeline. You're still going to have to do penetration testing on your software. You still need like a firewall in front of your application, right? The same kinds of things, but just different ones for the AI world, that's all. So you have new red teaming tools that are going to get built into your CI/CD pipeline. Natively integrated, that's going to give you a report, just like Sync and all those people, right? And then you're going to have this algorithmic red teaming, which is going to give you its own, which is going to do your pen test against your semantic, against your AI model, and that's going to tell you what your vulnerabilities are, what you need to be, sleepless at night about, right? And then for production, once you have your application deployed, then you're going to potentially use this runtime guardrails. You're going to say, I'm going to block prompt injections. I'm going to allow this kind of MCP traffic to go from here to there. Right, this asset access is allowed. This user is allowed to do that. So you're going to allow, or it's going to allow you to create those fine-grained controls that allow you. I mean, for any real-world system, yes, you have those complicated rules, and this is going to allow you to engineer those rules in, right, for an AI-driven semantic system. I hope that helps. Yeah. But yeah, again, we are trying to just piggyback on existing workflows, right, and then provide the same kind of solutions, but for a different AI world.
And so how do you buy it?
You can buy AI Defense. You can just reach out. In fact, we have demos on the floor right now, right, for anyone who's interested. I would just go down to the floor and have one of the product managers just show you what that means, right? You can look at what algorithmic teaming looks like, what the report looks like. You can see runtime guardrails, right? You can see some of those events, visibility, MCP, asset discovery, and stuff like that, right? Also, our integration story is pretty neat, I think, right? So in terms of being able to plug into your ID provider, in terms of one of the most common uses is like for us to plug into a secure access product, right? So if you have end users, so I have a Cisco Secure Client on my laptop, right? And any access to my cloud goes via Secure Access. And Secure Access is integrated to AI Defense, right? So if you're trying to send a prompt or if you're trying to use an AI application, that traffic is inspected by the AI Defense product already. So you start to get those protections, and then integrate it into the network as much as possible. So you don't have, it's not end user facing. You don't have to explicitly provision it.
Could you call out your three main differentiators against competitors like Prisma Harris from Palo Alto or Checkpoint and Akira?
That would be a very product question. So I would say that we are all building on the same kinds of things, right? But I think we have a stronger runtime guardrail protection story. right? I think we are much more advanced in terms of multi-agent systems, in terms of MCP, and in terms of supply chain. I think those are our primary strengths. In terms of or in terms of deploying a supply chain story, in terms of deploying an AI bomb story, right? We are able to scan your model files, scan your data sets, scan your libraries, code, right? Understand the provenance, and then make sure your CI/CD pipeline is good, right? That's one. In terms of our runtime guardrails, if you have an AI application already deployed, then you can choose a set of pre-existing policies. We are going to have a strong compliance and custom guardrail story very soon, right? I think that's going to be a strong differentiator, right? And then it's also about threat intel, right? We have a strong threat intel team that's really able to go out there and really understand what are the real world vulnerabilities that you need to be protected against. So we have a feed that comes in every week, every other week, that's updated, and so you get that real time protection that that you need. Yeah.